Welcome everyone to the Math 131 video practice on solving triangles in general. This will cover section 6.1 and 6.2 combined. You should have at least read over section 6.1 and 6.2 in the book before watching this worksheet video. Remember to print out the worksheet and pause the video, do the problem, then compare what I do in the video to what you did on paper. Keep in mind the following from section 6.1 and 6.2. As you are solving, once you get two angles, immediately apply the fact that the three angles in any triangle must add up to 180 degrees, the 180-degree rule. The largest side will be opposite to the largest angle, and likewise the smallest side will be opposite to the smallest angle. There can be at most one obtuse angle greater than 90 degrees. Work with the smallest side or angle possible for which enough information is present to apply one of our laws. Why? Because the two smaller angles must be acute. You do not necessarily know what the largest side is, acute or obtuse. To start with the law of sines, you will need a side along with the opposite side. Keep in mind the ambiguous case. If an angle A is acute, then it could be possible that another triangle could be formed using the angle 180 minus A, since sine A is equal to sine 180 minus A. If you cannot apply the law of sines, then try the law of cosines, which needs all three sides or an angle with the two adjacent sides. For both cases, choose to work with the smaller sides first. Otherwise, it is possible the ambiguous case could come into play and may implicitly give an invalid angle, something you might not catch. How should you start? For the given triangle, explain how you should start solving. You have only the three sides, so you must start with the law of cosines. Now, which angle should you find first? Angle A. Since A is the smallest side, you should be finding angle A. Therefore, you would not have an ambiguous case. Our second triangle, you have only one angle and you have the adjacent sides, so you must start with the law of cosines to find side C. Now, what angle are you first solving for? Second. In other words, we're going to find side C. I would like you to tell me which of these two angles you should be finding. Angle B, because we know B must be acute. There's no ambiguous case here. Just an FYI, we already have that C is obtuse, so A and B actually have to be acute. Notice C is already obtuse. We can only have one obtuse triangle. But again, if that wasn't the case, one thing I would know is that since 8 is smaller than 12, 8 would have to be associated with an acute angle B. Our third triangle, you have two angles. Once you have two angles, immediately find your third angle, the 180-degree rule. Now let me ask you, what side should you find next? Well, if angle B turns out to be smaller than angle A, so once we find angle B, if it turns out to be smaller than A, let's solve for side B. Otherwise, we'd solve for side A. Apply the law of sines. I work from smaller to larger to help me avoid the ambiguous case. Okay, let's continue here. Here's a triangle. Let's solve it. How should I start? You have two angles. Since we have the two angles, we find the third angle, 180-degree rule. Once you can use that rule, you should use it. What side should I find next, and how? Well, if angle B turns out to be smaller than angle C, we're going to solve for side B, otherwise side C. Then apply the law of sines. Now, I will note once again, I always try to work with the smaller side, smaller angle, if I can. Don't necessarily have to, but it's safer because I can avoid the ambiguous case which could sneak up and get me. All right, next one. Solve this triangle. How should we start? Well, you only have one angle. You have the adjacent side. So you must start with the law of cosines. My question now is, what side is on the left side of the law of cosines? Formula. And then what angle will I try to find next? Well, if we look at our triangle with the information we have angle A, side B, side C, and we're looking for, well, side A, right? Well, since we're working with angle 120, which is angle A is going to be on the left-hand side of the law of cosines. Notice, the important thing with the law of cosines is whatever side is over here, it is associated with the angle on the right-hand side. And the other two, right here and here, are the adjacent sides. So we're going to be working with side A on the left side. And then what angle will I try to find next? Well, we're going to find B next since B is smaller than C. So B must be acute. No ambiguity. By just observation of the numbers, why can't the following be a triangle? Our first one, why can't this be a triangle? All three angles do not add up to 180 degrees. So if you look and add these together, it adds up to 182. All three angles must add up to 180. Our next triangle, here's the information. Why can't it be a triangle? Since angle A is larger than angle C, side A must be larger than side C. So this can't be a triangle. Our third triangle, here's the information. Why can't it be a triangle? Angles B and C are equal. So both sides B and C have to be equal. So this can't be a triangle. Okay, here's our first triangle we are going to solve. We have a triangle. I'm going to draw a little picture over here. Side B is 1, side C is 9, and angle A is 120. So how are we going to start? Well, we start with the law of cosines with side A on the left, since we are given angle A. We have an angle with the two adjacent sides, so we're going to start with the law of cosines, and here we are. Side A, given right here, squared. Notice over here is the angle associated with A. Here are the two adjacent sides, right here and right here. So there is the law of cosines. When I solve this, I get A equal to 9.539390. I'm not going to be walking you through the work. That's prerequisite to all of this. Now I have side A, so I have 9.5. Now, let me remind you, we have to be careful with rounding. I'm not going to put the exact numbers over here necessarily, but when I work with my numbers, I'm going to keep this number in mind, because if you round too much too soon, you could cause significant errors. We now have side A, angle A, so we're going to work with the law of sines. What angle should we solve for next? So here's the picture right up here, right? Well, I know I can work with the law of sines because we have an angle and its opposite side. Since 1 is smaller than 9, I'm going to work with side B. And if I'm working with side B, I'm looking for angle B here. Why? Because B is smaller. So here's the work. Here is the law of sines right here. You fill in the details. We get angle B is something like 5.2. Now, where do I go next? Well, we have two angles. I'm going to find angle C by the 180-degree rule. So here's the 180-degree rule. And notice I'm being very careful with rounding. Now that I have all my sides, all my angles, I'm ready for my final answer. And always refer to the problem in terms of rounding. So here is my final answer. Here is our next triangle to solve for, which is actually an application problem. A tower leans at an angle of about 84.7 degrees. The figure here shows that 169 feet from the base of the tower, the angle of elevation is 50.4 degrees. Find the distance to the nearest foot from the base to the top of the tower. So in other words, we're looking for side B in the image. Now, how should we start? We have two angles. If we're given two angles, we should immediately find the third angle. So find angle C by the 180-degree rule. We get C is 44.9. Well, we now have side C. We have angle C. So we can apply the law of sines. What side should we solve for next? Well, since angle B is smaller than angle A, I choose to go with the smaller if I can. So I'm going to work with angle B right here to find side B along with the law of sines. So here's the law of sines. B over sine B, C over sine C. We solve, and B turns out to be 184.5. Again, we'll talk about rounding at the end. We avoid rounding during the intermediate work here. So we have side B. That is actually the side we're looking for. So the answer to the problem is 184 feet, because they wanted us to round to the nearest foot. Now, I'm going to finish the problem since we are trying to solve triangles here. So let me continue. I'll finish things off. So for side A, we're going to go with the law of sines. Why not the law of cosines? Well, you can. I just think the law of sines is easier. We know side A is going to be acute. No problem here. So there we go. Here is the law of sines working with side A, angle A, side C, angle C, and we get A as equal to 238.39 feet. Here is the next triangle we're going to solve for. You read it over. I'm going to get started drawing a picture here, but we are given side A, side B, and angle A. Now, since we have side A and angle A, we can start off with the law of sines. Now, what angle should we solve for next? Well, if you look at our picture here, essentially the only option is for angle B. So we're going to work with the law of sines. Sine B over side B is equal to sine angle A over side A. And we get B is about 25.7. All right? But am I missing something here? Think about this. Pause the video. Am I missing something here? It is possible that B could be obtuse. We don't have enough information here that would determine that B has to be acute. It is possible B could be obtuse. We will come back to this later. Let's finish solving this triangle. We have two angles, so we can find angle C by the 180-degree rule. So angle C is about 131.3. Working with side A, angle A, side C, angle C, we can work with the law of sines, and we can find side C, which is about 21.1. So our triangle, and again, going back to how they want us to round, here are the final answers. Or this is the solution to solving the triangle. Okay, this is a continuation of the previous problem. Remember, in the previous problem, we encountered the ambiguous case because we started the problem working with the law of sines. And if we start with the law of sines, it's possible, without enough information, that we could have the ambiguous case and it needs to be taken into consideration. All right, so from the previous case, it was possible. It is possible that B actually could be 180 minus 25.68, 154.31. This could result in a second triangle. In other words, we could have a triangle where this angle here is 154.3, unless we get a contradiction. Side A is 11, side B is 12.2, angle A is 23 degrees. So now we have two angles. We'll find angle C by the 180-degree rule. C is equal to 2.68. Oh, got that in the wrong place here, huh? 2.68. That's our angle. We can then find side C with the law of sines. We don't have any issues here, so we will get a second triangle. And that second triangle has the following results right here. And again, based upon how we were asked to round. Okay, here's an application problem that's involving triangles. So you read the problem. I'm going to get started here. Pause the video if necessary. But here is an image of the problem. And we're trying to find the distance between the houses. So we're trying to find this distance right here, which is actually side C. We're going to start with the law of cosines with side C on the left side, since we have the angle C and the two adjacent sides. So here is the law of cosines. Once again, notice the side here is associated with the angle here, and right here are the respective adjacent sides. We get side C is 34.4. So the answer to the problem is the houses are 34 feet apart. Now I'm going to continue to solve the triangle. Now, since we have an angle in the opposite side, we can start working with the law of sines. We have side C, we have angle C. The angle I'm going to look for next, well, I'm going to look for angle B, because 90 is smaller than 100. I definitely know that B has to be acute. So here is the law of sines. Sine B over side B, sine C over side C. We find that angle B is 63.38. Now we have two angles. We can find angle A using the 180-degree rule, and we get angle A is 96.61. So here is the solution to the triangle. Once again, the problem really only wanted side C, which was the distance between the two houses. Okay, our final problem. You read it over. Let me get started. But we have a triangle. We have side A. We have side C. We have angle A. I take note that I have an angle in the opposite side. So that tells me we can go with the law of sines. What angle should we solve for next? Well, it should be obvious that it has to be C. So here is the law of sines being put into play. We solve for angle C. It comes out to be 18.02. But since we started with the law of sines, could I be missing something? Is it possible that C could also be obtuse, meaning another triangle? No. Angle A is already obtuse, meaning angle A is the only angle that can be obtuse, so C cannot be obtuse. So this is the only possible angle C could take on. We have two angles. We find angle B by the 180-degree rule. So we have angle B now. And using the law of sines, we can find angle B. B over sine B is equal to side A over sine A. And we get B to be 26.6. So our triangle, and we're always referring to the problem in terms of rounding, here is the final answer. This concludes this video practice. I wish you the best. I hope it helped, and see you next time.